Hi, everybody. Welcome to Sacred Heart's Hour of Code. I'm Kevin Morris. Most people at Sacred Heart call me Kamo. And if you're here, you have probably gone through the tutorial for the Caesar Cipher. The first part, this is the second part where I'm going to help you write a Python program to do a Caesar Cipher. And I picked Python because it's a relatively simple language for us to do this task. It's not necessarily my favorite language, but it's perfectly suitable for this tool. So the first thing we need is a place to write Python. Now, some of you, if you're here, may actually have Python installed on your computer. I'm going to show you, I'm going to assume that you don't, although I'll show you at the end of this video how to install Python on your computer, which would be a different place to actually write the program. But it turns out, if you just go to Google in whatever browser you want, there is something called the GDB Python compiler. And so I just did a quick Google search for that. And the very, very first link that comes up is an online Python compiler. And don't let that word compiler scare you. Compiler just means a place to write code. And so this is actually a web page that somebody has done where you can write relatively short and quick Python programs just in the browser and run them. Disadvantage here is you can't really save it at all. So I'll talk about that at the end. That's why actually having Python really installed on your computer would be the better way to go. It gives you a little silly program here that just prints out hello world. It's kind of a tradition in computer science that the simplest program just prints out hello world. And if you run this, you'll see that down here, it just prints out hello world. Well, that's not what we're going to do. We're not going to do hello world. So just take all this stuff here and just delete it. And let's say I'm going to click this little tab right here to give myself some more space. And we're going to start writing a quick Python program. It's going to be about a dozen lines that is going to do the Caesar cipher, and now you understand what that means. Well, the first thing is we need to have some secret message that we want to encode. So I'm going to declare a variable. I'm going to declare a variable called message. And this is how in Python you declare a variable. You just mention it, equals input. And I'm going to say here, enter a secret message with a colon kind of as a prompt. Now, this is kind of a silly program. This is complete valid Python. Input is a built-in Python command that gets input from the user. And so if you run this, it's going to say enter a secret message. We're going to type hello world. But of course, our program doesn't do anything with that after that, right? But we'll eventually be doing something with that message. The next thing we need to know is that number of how far you want to shift it. Do you want to shift it to the right 3 or to the right 7 or whatever? So I'm going to make a variable that I'm going to call shift is equal to input, enter the shift number. And hopefully someone who understands what's going on here will know what that means. This actually would do one other kind of funky Python thing here, which is when you do the input command, it assumes that it's text. We are assuming they type in a number here. So I'm going to put int, saying for integer, and wrap this entire thing around this. It's kind of hard to read. Can I make that a little bigger? That looks a little bit better there. So you can see it. I'll make my little picture a little smaller. There we go. Can I do that? There we go. Yeah. So again, you have to wrap in this input command with int around it, which basically means consider this thing to be a number, not text. You can now run this, and it's going to say hello world. It's going to ask you want to shift it 6, but of course it won't do anything after that. So let's get it to do something. Well, in order to do something, we need to kind of have this idea of the alphabet, right? Like we're going to shift what's the letter, 4 after Q in the alphabet. So I'm going to declare a variable called alphabet. I'm just going to literally, in quotes, type in the entire alphabet in all caps. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. You can just sing yourself a song. Okay, you learned in preschool, right? So there's the alphabet. Now, I did the alphabet in all caps. And by the way, I put this in single quotes. I've been using single quotes the whole time. Python lets you do either single quotes or double quotes. So if double quotes is your jam, go ahead and do that. This is a problem with what if when I typed in hello world down here, I did a capital H, but a lowercase e. What we're going to do is I'm going to tag on one thing on this first line right here. So I'm going to write to upper. Sorry, just upper. Make my picture a little bit smaller so you can see it. Upper has a little open close parentheses after it. See, there it is right there. And this is going to basically take the message hello world or whatever the user types and convert it into uppercase. So we're not going to worry about, this is only going to be capital letters, which for this example is fine. Then what we are going to do is we want to kind of loop through the message one letter at a time, shifting the H, shifting the E, shifting the L, and so on. We're going to do this And we're going to make a new variable called result, which is going to start off at nothing. So this is an empty string. It's just an empty string variable. And when we process the H, we're going to build up our secret message one thing at a time. And the way we're going to do that is we're going to do for every letter in the message. This is a wonderful Python tool that basically says letter is the first letter in the message, the H. Then letter is the second letter, the E. Then letter is the L, that's the third letter, and so on and so on. Okay. So what do we want to do with this? Well, the first thing we want to say, we're going to kind of build up to this, but the first thing I want to say is pause is equal to, pause standing for just position. You could also call it index or P or place or I or whatever you wanted to call it, is alphabet dot index the letter. I want to talk about that kind of crazy line. Index is a built-in Python command that, given something, can find the position of it in something else. So the question is, at what number is the letter in the alphabet? So for example, let's say letter is the letter C, okay? You would expect that actually, where is the letter C in the alphabet? Well, it's the third letter. So you might expect pause to be the number 3, but you'd be wrong. It's actually the number 2, because in computer science, we always start counting at 0. So if letter was A, it would be 0. If letter was B, it would be 1. If letter was C, it would be 2, all the way down to if letter was Z. Z is the 26th letter of the alphabet, so you would expect pause to be 25. Okay, very, very common thing. Almost all computer languages that I know of start counting, start indexing at 0 in almost all cases. So now let's say the letter is H. Well, that would be 0, 1, 2, 3, 4, 5, 6, 7. So I think H is the 8th letter of the alphabet, so pause would be 7. What you want to do next is you want to say pause is equal to pause plus the shift. So let's say you're shifting it 3 more. Then you go from the H, you would go position 8, position 9, position whatever, and then you would get to the K, which is 3 beyond that letter, right? Okay, so then let's actually let's do something. We'll make a variable called new letter, and that's going to be alphabet bracket pause. And this is a kind of syntax explosion. Make a new variable called new letter, okay? And this is this crazy indexing into Python. Most languages do something very similar. Those are square brackets, and this says, give me the pause letter of the alphabet. So if pause happened to be 2, for example, then alphabet bracket pause would be the letter C. And then what do you want to do with that letter? Is you want to say result is equal to result plus the new letter. So let's say the letter is, let's say the thing was hello, then letter would start off at H, position would be the position of where that is. We would shift it, grab the new letter and add that to the result. That would be the encoding for the letter H. Then repeat for the E, repeat for the L, and subsequent thing after that. Should have mentioned this. You notice actually when you type this colon here in Python, it indents all this, okay? Python is militant about indenting. In fact, some of you may have used some other languages where it's like you need curly braces or something inside a block. The way you actually specify that these 4 lines are to be done inside this loop for every letter is the fact that they are indented. If you do something like this or something like this, Python won't like that. It has to be perfectly, perfectly indented, which does tend to make your code a lot more readable. So let's actually go now back to after the for loop. We're done with this. So if you're done, then actually we can just print. Print. It's a command in Python. I'm going to say encoded message is, and then after this, we'll put a comma. Actually, I'll do a colon here, encoded message, colon, and then the result, which is your secret encoded message. Okay. Now, this is pretty good. We have a couple things to worry about. Let's see if just that works. So if I run this now, I can enter the secret message. I'm just going to do hello here, not hello world, but just hello. I'm going to shift it 3. And it's kind of scrolled down, but look, there is my secret message. And in fact, that does work right? The H, the K is 3 after the H. The H is 3 after the E, the O is 3 after the L, and so on, right? There's actually 2 things wrong with this, because what if I shifted it way beyond like the letter Z? then it turns out, we might actually run up with errors. And in fact, I can kind of, that behavior is going to be weird if you try to shift things beyond the letter Z. So it turns out, let's go back to our code and test for that, right? When would you run into trouble? Well, I said that the Z is actually the 25th letter here, meaning position of 25th. We know Z is really the 26th letter, but if you start at 1, then you get to 26. If you start at 0, you get to 25. So what happens here if the position is greater than or equal to 26? That would mean Z has a position of 25. That would mean it's too big. Well, if that's the case, we can just say pause is equal to pause minus 26. So that will deal with like the wrapping around case, right? Now we're going to assume for right now that you're not going to shift it like, 3,912, where it's going to take multiple wrappings around. We're going to assume that your shift is a number, between kind of 1 and 26, right? So that should work right. Just to show you now, you can actually take the word hello, and I can shift it like 19. That's going to wrap almost all the letters or kind of wrap around. And you can see that that actually does work right. I'll make this up. You can see it there. There we go. And actually, we have shifted it to where the H wrapped all the way around to the A, and you can see the L's wrapped all the way around to the E's. Okay. Now, this is kind of great. We're almost done here, except there's one problem where, what if you wanted to type in like hello world? What do you do with that space, right? Because a space, when you say alphabet.index of and letter happens to be a space, there is no space in the alphabet, or is this also for things like punctuation or things? What should happen with things that are not actual letters? So let's deal with that. What I'm going to do is I'm going to say here, if the letter is in the alphabet, colon, and then all of these things here should get shifted over one. So there's a couple different ways to do that. I'm just going to right now just do it the kind of manual way, which is to go here, tab, 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 tab. There's another way to do it here, but it's hard to show in this video. So this would be the case for everything we've been kind of assuming that it's actually a letter, not like a piece of punctuation or a space. Then let's go here and say else, colon. What do you want to do if it actually was like a space or a piece of punctuation? Well, if that's the case, we kind of just want to leave it, right? So we're not going to try to encode exclamation parts, points, or spaces or something else. So let's just say result equals result plus letter. And so again, like, make sure you put this colon here, make sure you put this colon here, make sure your indenting is perfect. I'll kind of see if I can show you the whole program. There's our entire program. It's 15 lines. The indenting really, really, really matters. If you need to pause the video and make sure yours is working correctly, this should work. Okay. But let me show you what it does now. Watch what we can do. We can run this again. And we can now say like hello world. And to the shift number, let's do a shift of like 17. And then voila, see how the space actually kind of didn't get encoded. And you can now encode anything, okay? You could say, isn't the hour of code so fun? And then let's shift that by, 14. Look, there is the encrypted or encoded message, okay? Ta-da, you wrote thank you for doing this. This was really, really fun for me to do too. So there's the entire program. I mentioned at the beginning that we're doing this. I made this video kind of using this online GDB Python thing. So this does work, right? The problem is as soon as you close this tab in your browser or quick Chrome, this code is lost forever. So you worked hard on this. My recommendation is just select all of this right now and paste it someplace, okay? In a Google Doc or in your notes or something like that. I alluded to the fact that the better way to do this would be to actually install Python on your computer. And let me just kind of show you how you might do that. I'm not going to do the whole thing, but you can actually do a Google search. I just opened up a new tab for install Python. And it'll take you to a page called download Python. I'm not going to do the whole thing, but it's pretty obvious. You just would basically click this little button right here. It would completely download Python. When you do that, it installs the ability to write Python programs on your computer. And what you get actually is a program called idle in all It's actually in all caps, but I'm just gonna idle. I've already done this. So idle is on my computer. Okay. And then once you have idle open, I'll just show you this. I can actually make a new file. I'm going to go back here to this tab where I had the program. This was my program I worked hard on. I'm going to copy this. I've just done copy. Here we go. Now I can go back here to my new file and paste it. Okay. This is where you kind of would write Python if you didn't, if you once you have it installed. I'm now going to save this. Okay. I'm going to save it on my documents folder is fine. I don't know where I'll put it. I'll put it someplace. I'm going to call it like hour of code hoc.py. I'll put it on my desktop. And actually now it's saved forever. You can save it in your documents folder or whatever. And now just to show you, I can now run this program by going to the run menu and going run module. And it actually opens up here, and here it is. Like, I now know Python. Hooray. I'll shift that by, I don't know, 17. There's the encoded message. Okay. Running not in this web page, but on my computer. So I don't need internet access for that. And I can now save the file and come back and work on it later. Thank you guys so much for watching this video. Hopefully this has inspired you to do some more computer science, maybe to take some classes at Sacred Heart. I would always love to talk shop with you. So if you ever would want to come by my classroom, Campbell 156, and talk about some project you have or join the computer science club. If you're a computer scientist at Sacred Heart, I would love to get to know you. So thank you guys so much for doing the hour of code. Hopefully this was kind of fun. And if you still have any more time left, go ahead and look at some of the other options on that web page that we showed you. Thanks.